Everyone, thanks to be here today at our appointment focused on cluster analysis. I'm Cristina Carini, Workflow Program and FAO Account Manager, and together with my colleague Mattia Cefis, I'm pleased to introduce you to the theme of today's webinar. Okay. This is our agenda of today, and at first I want to devote a few minutes at SPS as a firm. SPS has been founded in 1994 and has been active in the world of statistical analysis and SPSS technology ever since. We are gold business partner of IBM and a certified entity to give direct support to our customers on SPSS. At SPS, we take care of our customers from assessing the need for statistical analysis to choosing the most suitable statistics for data analysis solution, to training on its use, of course. We collaborate with university, research center, public administration, association, and so on. And why do we talk about statistics for data analysis as a solution? Statistics for data analysis combines, along with SPSS statistical engine, our experience in the world of statistical analysis. In addition to supporting our customers directly, we sought tools that would allow us to share our knowledge. And so, in the solution, we put together operational tools, value-added services, together with SPSS statistics modules. And the first operational tools that I would introduce you is Launchbox. Launchbox is the gateway to the statistics worlds. It is your dashboard to keep in touch with SPS proposal for training, new features, opportunity, and so on. Downloading the Launchbox, you download in the same time add-ons. Add-ons are additional features built in natively, strengthening the tools, and are developed from SPS Factory. Today, my colleague Mattia will show you one add-ons in focus, that is a file division that we call split file. Together with the add-ons that I show you, there are some premium modules that SPS Factory has developed that are a UDEM module for define the cutoff of a ROC curve. And this is the script that you find in the solution for downloading. And P-score module for propensity score matching technique. Okay. In the Launchbox, there is a section with the date of the next webinar that we are working on our proposal for the autumn time, of course. And through Launchbox, you can reach the customer area. Recording of the appointment will be available there in the customer area. And also available is a form for submitting methodological questions, which will be answered by our support staff. And you find, of course, the answer that we have already give previously. Okay. In the Launchbox, you find some additional tools useful for managing the license, and of course, the user manual in English mother tongue, the last one. As operational tools, we have developed an app of statistics for data analysis to keep in touch with us via mobile. And so you can participate to webinars today through your mobile phone and to look at recording of the previous webinar. Is available for you an area with some tips and tricks that are suggestion to use your statistics for data analysis in a smarter way, of course. About our value-added services, is the services that we give through our technical assistants that are very useful if you find some difficulties in downloading the solution and for managing the movement of the solution from a PC to another, that in a daily activity it happens very frequently. And at our new customers, we are for sending the new version, the 29 version, that there are some interesting new features because base module added the features of bootstrapping and of data preparation that, you know, is very useful for your activity and the preparation of the data before analysis. Thanks to our expertise and the ongoing dialogue with our customers, a few years ago, we proposed our own statistics for data analysis configuration, designed to directly address the analysis needs of different fields, such as socio-economic, environmental, and so on. And we also have online training classes that we have strengthened our course offering and would love to become your partner for training on SPSS as well. Okay, this little summary. Now we reach the core of the appointment with Mattia, and that we talk about cluster analysis. And if you have any questions, please write in the question and answer area, and we will answer at the end of the webinar. Okay. Mattia?
I'm here, Christina.
Okay, could you share your presentation?
Yes, let me share my screen in just a moment.
Okay, you are
Okay.
ready.
Can you see my screen, Christina?
Of course, I see very well. If you wanna, okay, now it's bigger. Have a nice webinar. Thank you for your attention. Bye.
Perfect. Good morning to everyone. Thanks, Christina, for your introduction. I'm Mattia Cefis. I'm a data analysis teacher, and today I'm very glad to be here for presenting you by this webinar a very important trend topic as cluster analysis. Very interesting, in my opinion, from a statistician, but also for their large application in different research areas for this technique. Of course, this is a webinar. I show you some tips and suggestions in order to give you an idea, because it is a very, very large topic, and we would need many hours to in-depth it. But following our step, the contents include this brief introduction, right? The topic. Then just a few words related to the theory, the statistician theory under the cluster analysis, in order to have a clearer idea about it. Then I show you an example directly on the software. But let's begin following the next slide. Here, by this introduction, these three plots, I show you the main, not all, but the main statistician techniques available. And if we follow the red rectangles, we can reach the cluster analysis and see their classification, let's say. Cluster analysis belongs to the world of statistical learning methods and in particular to the non-supervised methods. Non-supervised methods are that group of techniques for which we have not an outcome variable, because all variables with multivariate data sets are included, are considered as at the same. For instance, they are considered both as the x variables. Okay, in order to have a clearer idea, we have not an outcome. The opposite situation we have with the supervised methods like regression and so on, in which we have the outcome variable, the so-called y variable. Okay, so we have not a target variable in non-supervised methods. Non-supervised methods are very useful as a preliminary analysis. After the classical descriptive statistics, non-supervised methods are very important for this purpose that I show you in the next slide. In fact, the cluster goal is first of all to discover a pattern between observations. In particular, it's very important to determine, and it's not automatically, but to discover, since it is an exploratory technique, to discover if there is a pattern among observation. And the second and main important goal is the segmentation. So segmentation, the data sets, so the units, we are focused on the units, the units of the data set, and to classify and discover if there is heterogeneity unobserved among units. Okay, since by the classical categorical variable, qualitative variables, we have the so-called heterogeneity observed, but by the clustering, any clustering techniques, we can discover the heterogeneity unobserved among units. This is the important thing related to this technique, this statistician tool. And when can we apply cluster analysis? It can be a very interesting question. We can potentially apply whatever the cluster analysis, since it is a very fast techniques, and for what concern their application, it can be useful in particular when there are heterogeneous observations, okay, among units. Units are when they are very heterogeneous, a cluster analysis is very useful to detect pattern among units. And it is not automatically that cluster analysis lets us a point results, a very pointed results. But it is since it is an exploratory tool, so we can apply it very fast, and to read and try to understand their results. We will see how in the next slide. In particular, the CA aims to group observations in order to obtain homogeneous groups. It has many applications in different kinds of research. For instance, in the scientific field, with large data sets for classifying animals, trees, minerals, geographic areas, and so on. In the marketing field, it is the main application. It was born for this application, cluster analysis, as for the marketing segmentation. In the sport field, again, to classify athletes' roles based on set of features, and again, another example in the clinic field for patients segmentation based on the medical record, and so on. So there are many areas of application for what concern cluster analysis. And now I show you a brief, just a few words related to the theory of clustering in order to understand better its goal and have a clearer idea about it. So the theory related to cluster analysis for what concern the statistician objective is the following. The main goal is to identify, okay, I told you very briefly in the previous slide, is to identify groups, okay, or cluster of similar objects within our datasets. This technique aims to split, okay, the data such that observations within each cluster defined are more similar to each other. In order to, it is an optimization problem in the statistician way. In order to obtain a maximum homogeneity inside each cluster, okay, or similarity, let's say, and the same a maximum heterogeneity between clusters. Okay, this is the objective from a statistician point of view. It's objective. And in order to detect, to make emerge this heterogeneity unobserved, it's very interesting because when we have a multivariate datasets, it helps us very, very well. And in particular, the step that we can follow for applying cluster analysis are the following. In particular, first of all, the classic dataset preparation. It means data understanding, data cleaning, and data preparation in general. Okay, after this first step, the measuring distance phase between statistical units for what concern quantitative variables, or we talk about similarity for qualitative ones. So these metrics are computed, and then the clustering algorithm works to detect the different groups, okay, homogeneous inside and heterogeneous between. And finally, the results analysis, so the interpretation, the reading phase of the results, and the final conclusion related to this exploratory tool. So this is these are the steps that I will show in the following example by SPSS. And here an example by this slide I show you related the distance computation between two statistical units. Here, this is an example related to quantitative variables, okay? Two typical metrics are the Euclidean distance based on the classical Pythagoras theorem and the Manhattan distance to use the various matrix. As you can see in the plot on the right, you can see the Euclidean distance among these two units, UK and UI, by the red line and by the blue segments, the Manhattan distance. In any case, any distance is symmetric and positive, so greater or equals 0, of course. So based on this example, okay, of computation for what concerns statistician and units distance, are based these clustering algorithms. But an important classification among there are many clustering algorithms, okay, in order to give you an idea. We can classify the clustering algorithms firstly in this way, by answering this question. Observations are classified just in one or more clusters at the end of the procedure. Okay. First of all, the first situation, if each unit is assigned to exactly only one cluster, we can talk about exclusive clustering. Otherwise, the opposite situation, the non-exclusive clusterings, allows units to belong to multiple clusters simultaneously. Okay. In particular, we will focus on the first group for exclusive clustering today in my example. Exclusive clustering, the main two subgroups are the hierarchical clustering and non-hierarchical clustering. In particular, I will show an example with the non-hierarchical clustering with the k-means algorithm. For what concerns hierarchical, there are two main approaches, the agglomerative and the divisive approach for this kind of clustering algorithms. that I show you in the next example, related hierarchical. This is an example of output related hierarchical clustering that shows us as output this plot that is called dendrogram. Dendrogram that for the agglomerative purpose works from the bottom to the top, whereas for divisive the opposite direction, and the distance, the final choice related the optimum number of cluster configuration is chosen by a trade-off among distance, okay, and the frequency table related to each cluster, the cluster memberships. This is the idea from the top situation, as you can see, is when all the units belongs to one cluster. So, and ideally the data set, of course. The bottom opposite situation, extremely situation, is when each unit is a cluster. Of course, we have to find a trade-off between these two extremely situation by hierarchical. Instead, with non-hierarchical, for instance, the k-means works very well with a large data set. And here I show you by this example, this simple example by these two dimension, x and y axis, how k-means is able to detect spherical clustering. Okay, before and after k-means, it's very strong, this algorithm, and fast. So as a summary of this comparison among the hierarchical and non-hierarchical clustering, as you can see, some pros and cons. Hierarchical clustering is very informative by the plot as the dendrogram, for instance. It's complete, it evaluates all possible aggregations among units. But with large sample size, it can be can have some computational problems, the hierarchical. For large sample size, I mean greater than 30, 40 units. Okay. For what concerns non-hierarchical, the k-means is very fast in computation and flexible algorithm. As cons, it's not, we have to set the initial cluster size. We have to know very well our topic, okay, in order to set the initial cluster size. And k-means it is not applicable with qualitative variables. Instead, the common problem is the final cluster size choice and interpretation, that it is not always simple, this final interpretation. But I show you better in the next in the example by the SPSS software. And now I move myself on the software by showing you the example. In the next slide, I'll showing the different step for implementing the k-means on the software. We can launch our software from the launch box, as introduced by my colleague previously, from the start button. And here I show you dataset, our example dataset. We will work with this dataset related 182 countries. And for each one, we have some economics indicators. If we go to the variable view, in the label set, we can read the description. We have the Human Development Index, the expectancy life at birth, the expected years of school, the mean years of school, and the gross national income per capita. So we have these features for each country. And the idea can be, okay, we have to classify in order to detect if exists the heterogeneity, some heterogeneity, okay, unobserved among these countries. And we can work in this way. First of all, briefly, statistician descriptive can we perform by the analyze menu, descriptive statistics. We can use descriptives, the descriptives menu and the explore or the explore as you want. I show you the descriptives now. Descriptives menu. Here you can see we have this box and we have to move in the variables blank box our descriptives, quantitative variables, and in order to have our descriptives values, and as option with option button we can set some other descriptives. By default there are mean, standard deviation, minimum, maximum. We can add variance and continue. And very important, I have to check this box in order to say standardized values as variables. Why? I do this one because it can be useful to have the standardized variables in order to remove the factor scale. Since we have different variables, each one has its own units of measurement, and it can be a problem in the final plot presentation. So if we have all variables standardized, we overpass that problem. So I set this one and I launch the procedure. Here in the output you can see the descriptive statistics, and it's clear. For instance, the magnitude of the units, it's important because if we have a look on the Human Development Index, the mean is 0.702 and so on. While if we have a look on the gross national income per capita, that is in dollar, I suppose, has this magnitude, 17,000 and so on. So and also the standard deviation and the variance are influenced by the scale factor. Okay, so based on this, we standardized all the variables. In our data set, we have now these standardized variables. We can detect, we can see those variables by the prefix Z, HDI, Z, expected life, and so on. These are the standardized variables. Okay. Generally, standardized variables have a range between -4 and +4. And take into account that standardized variable, for standardized variable 0, okay, 0, the value 0 means mean. So a score over 0, it means over the mean, and obviously under 0, lower than the mean. Okay, based on this preface, we are ready for applying our k-means. I show you. K-means, we can implement it by the analyze, okay, this way, by this way, analyze, classify, and finally, k-means cluster. I click here on k-means cluster. And here, if we press at all, we can see by default we have this situation, okay, for which we can change here on the right box, black box, and the quantitative variables we are interested to evaluate for the clustering. In particular, we will move on the right the z-scores for our 5 variables, and by default the number of clusters defined is 2. you can see. I suggest you to start from this configuration, okay? And then start from this and then growing, okay, the number of the cluster size in order to see step by step if the interpretation of the different clusters has sense, okay, is meaningful, because it is not automatic. Now there are, you can see on the top right of this box, different buttons: the iterate, the save, and the option. By the iterate, if I click here on this button, you can see the maximum iterations by default is 10. It's very fast, generally k-means, and but if we want, we can change it, this value. If, for instance, if we add a 0, maximum iteration 100, but in any case, it the procedure shows you an alert in the output if it exceeds the maximum number of iterations, since this is an iterative procedure that iterate and so on till convergence is achieved. Okay. Okay. Maximum iteration 100. I continue. Then there is the possibility to save the cluster membership, but we will do it in the following. We'll let it stay for the moment. And by the options button, we can set here, this is important, we can set and check the box related ANOVA table. Okay, it is very important, this table, since it suggests us which variables are important for segmentation. Okay, which variables are significant for segmentation. Now I continue, and there is also the possibility to write the final center of clusters, but we are not interested at the moment. Now I run the procedure by its button, and let's have a look on the output. The output is presented in this way. We have the initial cluster centers. Okay, for each variable we have cluster 1 and 2. Okay, and these cluster centers that are determined randomly, okay, by the algorithm. We are not interested in the initial cluster center. Then in the second table there is the iteration history. We can see the algorithm, the k-means converged in 8 iteration. The error decrease till arrive to 0 and reach convergence. Okay, it is very fast. And here we are interested in instead with the final cluster centers. We are interested in this table. This table is very useful in order to give it helps us to give to define a label for each cluster. Okay, that capture this heterogeneity unobserved. In particular, you can see the mean scores for each variables for each cluster. If we have a look on the first column related to the first cluster, you can see the score for each variable. Okay, that is for the first cluster, all a bit greater than the average, are both greater than 0, 0.69, 0.64, 0.63, and so on. While for the second cluster, we have the opposite situation. In the second cluster, there are countries with scores very lower than the average, than 0. For instance, the Human Development Index for the countries in the second cluster is -1, and so on. And the same for the other variables. And finally, the ANOVA table helps us to, as I said previously, to detect which variable are significant for the segmentation. We can detect it by the last column, the significantly column. In this case, all these p-values are so small, okay, lower than the cutoff of 0.05, classical cutoff. In this case, these are so very little. And it means that all these features are important and significant, statistically significant for the segmentation. Okay. Finally, the last out table that we have in the output is the frequency table. In particular, the number of cases in each cluster. In the cluster 1, the cluster with scores are a bit higher than the average for both variables. We have 108 countries, while in the second cluster we have 74 countries classified. Now we can, since for this configuration we have two clusters and we give a good interpretation, we can try if this good interpretation stays for another configuration, another framework with 3 clusters. We grow the number of clusters, for instance. From analyze, I rerun all the procedure, analyze, classify, k-means cluster. Here I modify this score. Now I try with 3 clusters. And I run the procedure again. Here you can see the output, so the initial cluster sentence. Here we have, as you can see, 3 clusters. The iteration history. Here it takes 10 iterations to reach convergence. And the final cluster centers, have a look on these important results. As you can see, despite the previous framework, the previously cluster 1 was in this case split into cluster 1 and cluster 2. In particular, the cluster 1 has scores around the average, very around the average, very small around the average. The greater in positive is 0.3 and the greater in negative is minus 0.25 and so on. So are both scores around the average. And while in the second cluster, we can see a higher magnitude in positive for each score. As you can see, we have both variables greater or around 1, so very greater than 0, so very greater than the average. So we can, if we want to give a label for each cluster, we can say, okay, the first cluster is let's say the equilibrium cluster, okay, around mean. The second cluster is the greater than the average cluster, and the third cluster is very similar to the previous one, the previous framework, with both scores very lower than the average, under the average. If we have a look on the ANOVA, all variables stays significantly for segmentation, and in addition, the F-score, this column related to F-score, reveals a high magnitude for what concerns the segmentation. But the most important thing is the significantly, are both significantly for the segmentation. It's okay. And finally, as you can see, the number of cases, so the frequency table, we have 78 countries in the equilibrium cluster, 46 in the over average, that's called in this way cluster, and 58 countries in the third one. So in addition, we have a very interesting, very good partitioning, very good segmentation. So it seems to have sense the cluster analysis in this way. If, for instance, you have in the final number of cases this frequency, you have just one units in one cluster, all the other units in the other one. That means that cluster analysis has no sense in that case. Okay. Just to in depth the fact that cluster analysis is not always the solution. It is an exploratory tool. Okay, it can be very important, but it's not automatic. Okay. Now I show you the possibility to save the cluster membership. I rerun fastly the procedure, analyze, classify. It means by the save button, I can check this box, the cluster membership. Let's continue. And we are ready with the free cluster configuration. I run the procedure again. We have the same results as before. And if we move on our data sets, we can read this new column, this new variable, the QCL1 variable with the cluster memberships for each country, for each unit. Okay, and if now we can change by the variable view menu the name of the variable. For instance, I rename this variable with the CL cluster free config, and the values column in order to give a label for each configuration. By this button, this plus button, the value for each value, I give a label. The value 1 is the, let's call equilibrium this way, equilibrium cluster. By plus, I set the number 2 with the greater than average cluster. Again, the cluster 3 is the lower than average cluster. So we have a label, and it's very important. Now, if we move on the data view, you can read by this column the label. If we change the view by this button, the value labels, you can see the category 1, 2, or 3, or the label. Okay. It can be very useful if we close this dataset, and if we reopen it in 2 months, in the next year, and so on. So it can be immediately the interpretation if we give a label. Okay, it's very useful in my opinion. And now we are ready to try to see some output view. For instance, I show you the equivalent plot of this table of the final cluster centers that can be useful and immediately as interpretation, the final cluster centers, by this plot. Let's follow this way by graphs, legacy dialogues, bar plots. We are in the bar charts menu, okay? And now I choose the clustered option and the voice summaries of separate variables, since we have 5 multivariate datasets with 5 standardized variables. Now I can define, and here, where is it? Here by this box, I move in the bars blank box the 5 Z scores. Okay, and in the category axis, I put the cluster number. Okay, so the CL free config variable in order to have the label. Okay, and now I run the plot, and here you can see the equivalent as a plot of this table, the final cluster centers. And here is immediately the interpretation. It's easier. You can see the equilibrium cluster with values around 0, around the mean. The global mean is 0. And the GA cluster with both scores, both variables, countries with variables greater, with score greater than the average, and the opposite for the LA cluster. Now it's immediately, you can see by its color the legend for each variable, and in the light blue, the human development index still arrived to the gross national income per capita for the with the brown bar plot. And now another representation can be a bidimensional representation that I show you, for instance, related to variables that are quite correlated. So the expected years of school and the mean years of school. I can show you by a scatter plot in this way, by this path. Graphs, legacy, scatter plot, the simple scatter, define, and here I put in the x-axis the mean years of school, and in the y-axis the expected years of school, while in the set markers by cluster in order to have a different cloud. Okay, and if we want, we can add the country as label cases. In order to view the label cases, we have to check this one. By the option button, we have to check this box, this one, display chart with case labels. Now, let's continue and let's run the plots. And here you can see this plot, this scatter plot, with these two variables, and it's very interesting to see the free spherical clustering. Take into account that the clustering in this way, in this example, works with multidimensional, so with 5 variables. Okay, this is a subcase with 2 variables. Okay, since it is a multivariate procedure, and we cannot display by a chart 5 dimension. Okay, I show you this one as example. You can see in the bottom left of the plot by the red purple points, the LA cluster. Okay, you can see some Africans and Latin American and some Asian countries. Here in the middle, the equilibrium cluster, we call it in this way, with some Asian countries, and not only, and some Latin too. And in the top right, by the green points, some European, American, and other countries. So it's it's very interesting, this visualization. Now we can, if we prefer, we can remove the label cases, legacy dialogues, very fast, scatter, define. I remove the label cases just to see this one, this representation. You can see this cluster, this one, and this other, these 3 clusters by this bidimensional plot, these 2 variables, but take into account that it works with 5 variables. Okay. in a multidimensional space, since these exploratory tools are all also are multidimensional tools. And if we finally, I come back to the data set. If you are interested, for instance, this can be a first step for further analysis. For regression, we can use then this an observed heterogeneity configuration for further and in-depth analysis, regression, and so on. Okay. And in addition, by some extension and other function, we can, if you want, divide our dataset by the clustering config. Okay. If we want, this is for this example, but if you want for another category variables, another qualitative variables, in this way, by this add-on, by the data, if we follow this way, data, and split into files. This is an example of practical add-on to split our file, our cases by a qualitative variable. For instance, the number of clusters. Split cases by this variable. We can set the output file directory here by browse and decide the path for directory. And finally, let's start by let's run the procedure, and it will create automatically in that path 3 clusters. In this way, 3 because we have 3 clusters, and in this way it's better the 3 cluster configuration than the 2-1, because it's very clear and it let us a deeper interpretation of this unobserved heterogeneity. Okay. This is the example of for this add-on. And I come back to the slide in order to give you a conclusion and a summary related to this presentation, this webinar. So as conclusion, in general, cluster analysis techniques are okay. We can run these techniques with quantitative or qualitative variables following that the data and the techniques. It is an exploratory analysis, and for unit segmentation with a large number of observations, the non-hierarchical clustering is better. And we can repeat the analysis with different cluster sizes. There is no a punctual solution, okay? Since these are very fast techniques, we can repeat the analysis. And it is can be very useful as first step for further analysis, for instance, the regression and many other ones. So I conclude my presentation, and I thank you for your very, very kind attention.
Thank you too, Mattia. And yes, we have received some questions.
Great.
Okay. I read you the first. Can we use cluster analysis with the questionnaire data?
With questionnaire data, yes, we can use it. There exists some techniques for this kind of items. For instance, one example is the hierarchical, but other ones, for instance, the two-step clustering.
Okay. And we received this question a lot of time. I read you. How many cluster is better, 2 or 3?
In our example, as I said, 3, because it's a deeper interpretation and explanation.
Okay, and I think that your answer is useful for the question too. Is there is there an objective criterion to establish which is the best number of clusters?
It exists an index, so the silhouette index, but it's more useful also to use our knowledge and expertise because for each situation it changes.
Okay, okay. Another question. Is a cluster analysis a correlation or is it like this one?
No, cluster analysis, it's not a correlation. No, 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 no. It's an exploratory tool, and it can be useful as first step for further analysis, for regression, and many advanced ones.
Okay, I read you another one. Is it possible to cluster heterogeneous data? Ordinal, frequency, continuous. Sorry, but I haven't understood very well the question.
Don't worry. I think yes, yes. If I understand the question, yes, it's possible, but there exist many, as I said, there exist many clustering techniques for any kind of data. For instance, the two-step is a meeting point that works with both any kind of data, for instance.
Okay, the last one. K-means is not usable with questionnaires, even though we conduct a factor analysis on data first.
Yes, K-means it's not okay with this kind of data. It's okay with quantitative, just quantitative variable. And in that case can be useful the two-step or the hierarchical. And it's cluster analysis in general, it's very used in a tandem analysis with factor analysis or PCA. Yes.
Okay, Mattia. The last one for sure. When we find a non-significant variable in the ANOVA table, we should remove it.
It's we can do two things, or try a grower cluster configuration, okay, in order to see if it means significantly, okay, or otherwise yes, we can remove it since it is
Okay.
not important for the experimentation.
Okay, thank you very much, Mattia. Now I use this last minutes for some other little information, okay, and for our okay. If you need some other information about our training offering, please keep in touch with us. And you are going to receive a survey in order to give us your feedback about the presentation of today. And please answer because your suggestions are very useful for us to set our future activity. And you will receive the link to look at the recording of today, and we will share the presentation on our LinkedIn page of SPS, and from all SPS team, have a nice summertime. Now today you heard Mattia and me, but to make happen the webinar of today, some other colleagues have worked, and so we would like to thank Serena, Elisa, and Laura, of course, too. And nothing else. If you need some other information, please keep in touch with us. You find here our contact data. And so have a nice day. Thank you, Mattia, and thank you everyone for
Thank
your
you,
attention.
Christina.
Ciao,
Thanks to
bye-bye.
everyone. Bye bye. Thank you.
Bye bye.